All right, two sides of a triangle have fixed lengths. I've shown this triangle as it's described in a couple of different positions. We have two sides that are locked in at 20 and 24. Here they are again. And then this third side is getting stretched. And as it gets bigger, it's spreading the 20 and the 24 further apart. And what they're asking about is the angle between the fixed sides, which I'm going to label theta in both of these cases. And of course, that angle is going to open up as side C gets bigger and bigger. And they ask when this side makes it to 15 centimeters, how fast is the angle increasing? So we need some way of tying this side in with the angle across from it. And the cosine law does this wonderfully, and nothing else really works at all. So the cosine law says c squared equals a squared plus, it's kind of the Pythagorean theorem, but with an extra modification built in to account for the fact that it's not a right triangle. So A and B are our fixed sides, 20 and 24. Theta is the included angle, and C is this growing side. We can make this simpler. Fortunately, I'd hate to take the derivative of this thing as it is right now, because here we have A times B times cosine theta. We'd get mega product rule over here if we did this as is. But the good news is A and B are fixed, so we can put their values in right now. We can say A squared is 20 squared, that's 400. B squared is 24 squared, which I think is 576, but I'm going to double check because it would be embarrassing to mess that up. Yep. 576 minus 2 times 20 times 24 times the cosine of, and the angle is variable, so we have to leave it as a variable like we have here. So c squared equals, add those up, you get 976. And then we get 2 times 20 is 40, times 24 is 960 cosine theta. And I think that's about as nice as we can make the angle formula look. Now that it's like this, we can differentiate it, and it's not too terribly bad. We get, on this side, 2c dc. The derivative of 976 is 0 because this is a constant. And then here we get, the derivative goes through the minus 960, and it runs into the cosine. The derivative of cosine is negative sine theta d theta. And we divide both sides by dt, because we pretty much always do that. And we get 2c dc dt equals negative times negative is positive 960 sine theta d theta dt. I really want to divide both sides of this by 2. The question is, am I too lazy to rewrite it again? I'm going to divide this by 2 and just take advantage of the computer's ability to erase. So on the left side, I'm going to divide by 2, and that 2 is going to go. On the right side, I'm going to divide by 2, and 960 is going to become 480. Good. Okay. Now, we're trying to find the rate of change of the angle d theta dt, so it's all this other stuff that we must fill in. Let's see how much stuff we know. C is the length of this growing side, and they told us it's 15 centimeters, so that comes easy. dc dt is how fast that side is growing, and they tell us it's happening at 3.5 meters per second. Sorry, centimeters per second. Equals 480. We haven't done a sine calculation yet. I have a feeling one of those is going to run into us real quick here. Sine theta. What's this angle? Do we know it? No, we don't. Can we get it? Well, if we know this side is 15, that seems like it might help somehow. I'm going to put 15 up here. That's the point we're really interested in. How do we get the value of that angle? This isn't a right triangle, so if you're thinking anything about SOHCAHTOA, stop. That stuff's no good unless we know we have a 90-degree angle in here. But we do have the sine law. The sine law might be able to help. Or can the sine law help? We have this angle, we have the opposite side, we have these two sides, but we don't have either of those angles. No, I think we have to use the cosine law, actually. We have to dig it out of here. It's going to have to be this. We can get a theta out of this if we're clever enough. Our c is 15, so we get 15 squared equals 976 minus 960 cosine theta. 15 squared is 225. Da, 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 da. 976 minus 960 cosine theta. Subtract 976 from each side, and we get minus 751 equals minus 960 cosine theta. Divide both sides by negative 960, and we get cosine theta equals 0.782. Inverse cosine or arc cosine, and we get that angle is 38.5 degrees. So good. There's our angle. That side calculation was almost as much work as all the rest of the problem, which I'm afraid is not too unusual. But, oh well, we got through it. And d theta dt is the thing we're trying to solve for. So, there's that. Okay, so to get d theta dt, we do 15 times 3.5, and we divide that by 480. And making sure we're in degree mode, we also divide that by the sine of 38.5 degrees. And I get that d theta dt, our angle rate, is 0.176, and it's angle units over time units, which in this case would be radians per second. Rad per sec. Makes sense that the angle is increasing because this side is getting bigger. When a side of a triangle increases, the opposite angle has to increase.